Let's do day 6. Guard Gallivant. Single guard is patrolling this part of the lab. Where the guard will go, there is a map. I see some character. That's the guard position. And hash is a wall, some kind of abstraction. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. And eventually we'll leave the area, unless we go in infinite cycles, right? We wonder which cells will be visited. How many distinct positions will the guard visit before leaving the mapped area? There are 41 here. It seems like there aren't many X's here. 7. Okay, I believe that. Get your puzzle input in. Right, 130. Well, we just need to continue. So it will be a while loop where we stop if we try to go outside, or if we repeat the state, but apparently they say that we stop when we go outside. So I assume that we will not go forever. 130 lines. In every row, read that row of the grid. A of H. I could call this grid, but then I need to use it so many times that A is just so much more convenient. The width is length of the first string, let's say. And then we start at the position of this character, and immediately I will try to change it to a dot so that in the future I could pass through it. Maybe here, well, okay, let's do it here. Let's not mix reading and actual problem solving. For every cell, maybe let's start using row and column. For every row and column, if this cell is this character, then what? I don't know, me is equal to row column. This is where I am. I start here, and additionally A of row column becomes a dot. Also, my direction is up. I need to have array of 4 directions. If I go up, I modify the row by -1 and column by 0, and then if I rotate right, which is next, I increase row by 0, column by 1, then 1 0, and then 0 -1. The order here is very important, because I will say that by default my direction is 0. That's the index in this array of 4 elements. And when I turn right, I will just do direction plus plus modulo 4. So there is this thing and that. That together describes where I am and where I face. While true, while I'm inside the grid, I try to move forward. So I try to move me first plus directions of their dot first. Column is second plus directions of their dot second. And there are a few possibilities. First is that it's outside the grid, then I stop. If not inside of R2C2, well, I will only use it here. So if not true that this is true, R2 smaller than H. If this is not true, then break, because we are outside the grid. Otherwise, if A of R2C2 is a dot, I just go there. Me is equal to that, and direction doesn't change. Else, if this is a hash, I cannot go there. Then we increase the direction by 1 modulo 4. So we just move to the next of those directions listed at the top. And then we need to additionally count the cells that are visited. I could use a set or hash set. and I will do that, but be aware that significantly better method is to use a two-dimensional Boolean array, because set and hash set has a big either time complexity or constant factor. Boolean arrays are almost always better. Visited, insert the current cell, and then print visited.size. Ignore that, that's my compiler. 4433, that's a nice result. And that's the right answer, part 2. Record the nightly status of post on the walls of the closet. Adding a single construction. The guard will get stuck in a loop. All possible positions for such an abstraction. I wonder if this can be done fast without actually iterating all possibilities. How many different positions could you choose for this abstraction? I guess we can represent the whole thing as a graph and maybe solve it fast, but I'm going to just do a brute force. In the next few days I will think if this can be done better. If so, I will let you know in the comments. But here I'm just going to solve it by trying all positions, and for each of them separately running the algorithm. So what we need to do is we still read, sure, and then for every position, here, for every position, if this is a dot right now, then consider moving it to a hash. Also, it cannot be guard position, so me cannot be equal to row column. So it's not the starting position, it's just a normal dot. Then we do this, we check something, and then we move it back to a dot. And what we do here is we run the whole logic, this thing, but we stop when we go into a cycle. Should I make a function? Sure. I don't know, run, solve, whatever. So there is this thing here, and I will just say if solve cycle, then answer plus plus. Answer will count how many cells there are such that we go into a cycle instead of going outside of the grid. One way to verify if something is a cycle would be to just make a lot of steps. So I'm going to solve it two ways, just to be sure that the answer is correct. First is that I'm going to count the number of moves, how many moves I make. So we do this, turns plus plus, and now if turns is equal to, let's say, 100,000, then return true, that this is indeed a cycle if I move so long. Solve cycle, right? This is what I called it. Yes. And finally, if I break, this means that we're outside, then return false. And that's it. So that's the first way how we can solve it. 0, that's suspicious. We always move outside. That shouldn't be the case, should it? How do I debug this? I'm not going to debug it using this test. By the way, where is the guard? Here. If I do this, so if I just consider every dot, I will get some answer, right? Yeah, a lot of cells considered. And apparently this never returns true. If I change this to just 100 turns, I will get something, right? Yeah, 50 and 4, and nothing continues longer apparently. For this, 4 times size of the grid would be enough, but that's not the point. Some code must be correct because I've already used it for the easy version. Well, let's try the sample test. Even that is too big. I'm going to create my own test into. It will be just 3 by 3. We start maybe slightly bigger because I don't know if I will fit the cycle there. I want to have a hash here. We will start there, hash here. Then, so if I go there, then I start going down, hash here, hash here. This should be a cycle. Actually, if I run 0.6 on this, just not hard coding this. If I run that, it should say that it's a cycle. Yes, it runs forever. That's right. Then for this part, what will I print? Not, I want part 2. On the into 4. There are 4 positions. Why 4? It should be almost everything. Or does it count the hashes? Why is it 4? Let's print the row and column in this case. For what rows and columns does it decide that it's okay? 0, 0, 0, 2, 0, 3, 1, 0, and is it coincidence that it stops exactly when it sees the guard? Yes, that was a coincidence. Okay, why only those cells? Oh, direction equal to 0. And me. This thing should be resetted every time. Right, yeah. I once compute where the guard is and what is the starting direction. And then I should reassign this every time when I start a new journey. It should go from the beginning. For efficiency, let's just here say start me is me, start direction is direction. Well, that's just 0. But now me is equal to start me, direction is 0. Well, this should be enough. Me is start me. This is where the guard starts. And we'll start me. Now 8 cells, that makes more sense. Okay, so problem solved, I think. But I told you that I'm going to make this better. So we can do this. We can also here, well, we can count how many cells there are. And that's height times width. Each of them we can be in 4 different positions. So the exact limit I could use here is h times w times 4. And this should be correct. If I repeat that many turns, let's say +1, it means that already I was in every cell in every way. So for sure this is a cycle. But there is even better way. So this time I don't need to count visited cells. I want to say if I'm anywhere facing the same direction for the second time, then this is already a cycle. So the fastest way, maybe not by constant factor, but it is to mark visited states. And the current state will be row, column, and the direction. Now, if visited counts, if it already has a vector of me.first, me.second, and the direction, then return true. Otherwise, just insert this. That can be one-lined in C++. You can say visit insert, I think .second. Insert both inserts something and checks if it's already there, if I'm not mistaken. The answer didn't change, so most likely it's correct. Now, if you don't use hash set, instead if you use set, then it's additional login time complexity. Why is it infinite? Did I mess something up? Maybe. Should I say this? Something strange happened. Something strange happened. 11 cells. What if there is a hash here? Then I will go outside, so that shouldn't be the case. Now I'm not that sure. Let's see what the correct answer should be. If I do this, then that should be correct, right? 130, 130, 15, 16. That's certainly not equal to 16,000. Does it make sense that the program is just so slow? No. What does the insert exactly return? C++ set insert. The second element is a Boolean value, right? And the bool value set to true if and only if the insertion took place. So if it didn't took place, then we return true. That should be the case. And then it's extremely slow. Is it infinite? Why is it infinite? Let's, well, print the starting position. Why did we multiple times print the same starting position? Well, okay, that's obviously correct. The point is that we have different blocked cells, so I should print it here. It's just so slow. Is it just because of a constant factor with this? We saw that answer already. Maybe I will submit this and then think some more. That's the right answer, all right. So apparently by introducing this set, I slowed the program down like 50 times. Interesting. Let's try to make it blazing fast. I told you already today that Boolean arrays are fast. So what if I create a Boolean array of this size? This will encode the value of row, column, and the direction. Then I can say that like it's like a hash, but without collisions. The cell is row times width plus column, and this I can multiply by 4 and add the current direction. This will be a value that represents the current state. Then if visited of hash return true, and otherwise visited of hash becomes true. So this should be the fastest possible solution, where we stop whenever possible. What is not correct? Row and column. That's me.first, me.second. Still, it took some time. Why? Maybe it's unnecessary to even create this array. Is it faster if I do this? Oh no, it wasn't faster. So perfectly I should do that thing. And then it's similar. Okay. Then I guess this speed up with the Boolean array, it makes sense only if very often we get short cycles, and if the test is big and mostly small, then we don't really get often into big cycles. So at the end, let's say that this is my solution, with the alternative being that we check the turns. Right. Okay, that's it. The full code is 70 lines. To summarize, after reading the input, saving the starting position of a guard, I have this function which verifies what happens now if I start from the starting position. What I do here is for every position that is a dot and not the starting place of a guard, I run this thing to check if I go into a cycle. How do I check for a cycle? I remember states in terms of where I am and what direction I'm facing. This can be encoded as a value from 0 to this thing. That's a formula that you can use to encode the state into a value. Like if I'm in cell 0, 0 with direction equal to 0, this will give me value of 0. If I'm in 0, 0 with direction of 1, it will give me a value of 1. And so on. If I'm in 0, 1 with direction of 0, it will give me a value of 4, and so on. You can analyze what exactly this does. But yeah, that's one way to do it. Then if I already was here with the same direction faced, then this is a cycle. If I try to go outside, then there is no cycle, and that's it. I just follow the logic from the easy version. The time complexity of all the solutions I presented is size of the grid multiplied by single run to find the cycle or not, which is again this. So this is size of the grid squared basically. And it is possible, I guess, to obtain just linear time complexity, h times w, linear of size of the grid, by creating a directed graph of our transitions. Then we only change it a little bit whenever we put a hash somewhere. And maybe it can be done to quickly then check if something goes into a cycle or not. I will think about it, and as I said, if I figure something out, I will let you know in the comment. And that's it today. Next few days I'm out of town conducting some ICPC programming camp, so for days 7, 8, do not wait for my videos. Maybe on Monday or Tuesday I will upload a video, or I will make a live stream with days 7, 8 and 9. Thank you for watching today. See you next time. Bye.